Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. So I will continue my video lesson for CAIE 5070 past paper. So I was doing paper 1 for specimen for the version 2023 and onwards. So I've already completed question 10. So let's continue the video with MCQ number 11. The equation for the reaction between ethyne C2H2 and oxygen is shown. 2C2H2 XO2 YCO2 plus ZH2O. When the equation is balanced, what is X? So what we will do, we will simply balance this reaction equation, then we'll get the correct balanced form of this equation. I'm writing the equation here. 2C2H2 plus XO2. I'm not writing X here. Getting CO2 plus H2O. Now start balancing the equation. We have 4 carbon atoms on the left hand side or the reactant side of the reaction. So I will write 4 before CO2. Hydrogen is also 4 on the left hand side of the reaction equation. So I will write 2 here. Now let's start counting the oxygen atom on the right hand side. 4 2s are 8 plus 2. It will be 10. So I will write 5 here. So the correct answer for this question should be D. Number 12. 25 grams of hydrated copper 2 sulfate crystals are heated to produce anhydrous copper 2 sulfate and water. CuSO4.5H2O solid gives CuSO4 solid plus 5H2O. What is the mass of anhydrous copper 2 sulfate formed? MR of CuSO4 and H2O is provided. So what we will do, I'm writing the equation here on the right hand side. CuSO4.5H2O. They are asking the mass of the anhydrous copper 2 sulfate, so I'll write CuSO4. Simply express their MR in grams. So first of all, you need to calculate the MR of CuSO4.5H2O. So it should be CuSO4.5H2O. For CuSO4, it's given, it's 160 plus. The MR of water is also given, so you will multiply 18 by 5. What you will get? 5, 8, 40 should be 90. So 160 plus 90 should be 250. So you write 250 grams copper sulfate dot 5H2O gives 160 grams of CuSO4. Therefore, 25 grams gives X gram of CuSO4 anhydrous. So it will be X is equal to 160 multiplied by 25 divided by 250. So 1 times 25, 10 times 250. So answer should be 16. This is the correct answer for this choice. Multiple choice. Number 13. The relative formula masses of 4 compounds are given. A student has a 1 gram sample of each compound. Which sample contains the highest number of moles of oxygen atoms? Relative formula mass for each compound is given. So what I will do, I will convert all these relative formula mass into moles. So it will become then easier for us to calculate the highest number of moles of oxygen atom in one of these compounds. For Al2O3, 1 divided by 102 gives 0.009 moles. For CuO, 1 divided by 80 gives 0.0125 moles. For H2SO4, 1 divided by 98 gives 0.0102 moles. The last one, 1 divided by 63, 0.0158 moles. So for Al2O3, we have 3 moles of oxygen. So I will write 1 mole gives 3 moles of oxygen. Therefore, 0.009 moles gives X moles. So answer will be X is equal to 3 multiplied by 0.009. So the final answer will be 0.027. 0.027. So I will write here 0.027. These are the moles of oxygen. For CuO, as a formula implies, is 1 mole of oxygen. So no need to do the calculation. 0.0125 mole gives 0.0125 moles of oxygen. So I will write here 0.0125 moles of oxygen. For H2SO4, we have 4 moles of oxygen. 1 mole contain 4 moles. Therefore, 0.0102 mole contain X mole. So X is equal to 4 multiplied by 0.0102, which will become 4 multiplied by 0.0102, 0.0408, 0.0408. For the last one, that is HNO3. We have 3 moles of oxygen. 1 mole contain 3 moles. Therefore, 0.0158 mole contains X. So X is equal to, you will multiply 3 by 0.0158. 0.0158 multiplied by 3. 0.0474. So the correct answer should be HNO3. D should be the correct answer. Number 14. 50 centimeter cube of 0.1 mole per dm cube silver nitrate AgNO3 is added to 150 centimeter cube of 0.05 mole per dm cube sodium iodide NaI in a beaker. After the reaction, solid silver iodide is present in the beaker. What else is present? First of all, I'm going to write the reaction equation. Reaction equation will be like this: AgNO3 plus NaI. The products are sodium iodide, silver iodide, Agi plus sodium nitrate. You see the ratio for both the reactant is 1:1. So first of all, I'm going to find the limiting and excess reactant in this reaction. Once you know the excess and limiting reactant, so excess reactant will be the one which will be left with the product in this reaction. So the volume and concentration for both silver nitrate and sodium iodide is given. So I'm going to convert this into moles for AgNO3 and NaI. For AgNO3, I'm doing it on the left hand side. 1000 centimeter cube contains 0.1 mole. Therefore, 50 centimeter cube contains x mole. So it will be x is equal to 0.1 multiplied by 50 divided by 1000. 0.1 multiplied by 50 divided by 1000. Answer will be 0.005 moles of AgNO3. Now let's calculate the mole for sodium iodide, NaI. According to the information, 150 centimeter cube of 0.05 mole per dm cube of sodium iodide is reacted. So I will write 1000 centimeter cube contains 0.05 moles. Therefore, 150 centimeter cube contains x moles. So you will get x is equal to 0.05 multiplied by 150 divided by 1000. So what we will get? 0.05 multiplied by 150 divided by 1000. 0.0075. So that clearly indicates in both of these reactants, sodium iodide is in excess. So in the answer, you must have sodium iodide as one of the substance present in the reaction mixture of in beaker. So choice B should be the correct answer for this one. 15. When 0.1 mole of the hydrocarbon C5H12 is completely combusted, it produces carbon dioxide, CO2, and water H2O. This is the reaction equation. C5H12 plus 8O2 gives 5CO2 plus 6H2O. What is the volume of carbon dioxide produced when measured at room temperature and pressure? So first of all, check the reaction equation whether it is balanced or not. Let's count the carbon atoms on both sides. It's 5. Carbon is balanced. What about hydrogen? It's 12 on the reactant side. On the product side, it's 12. What about oxygen? Oxygen is 16 on the reactant side. On the product side, 5 multiplied by 2, it's 10. 10 plus 6 is 16. So it means oxygen is also balanced on both sides of the reaction equation. Now let's proceed. They are asking what is the volume of carbon dioxide produced when measured at room temperature and pressure. The moles of C5H12 is given. So we'll write C5H12 gives 5 moles of CO2. So we will write 1 mole produces 5 moles of CO2. Therefore, 0.1 mole produces x mole of CO2. Do the cross, what you will get? You will get x is equal to 5 multiplied by 0.1 is equal to 0.5 moles of carbon dioxide. And we know that at RTP, for any gas, 1 mole is contains 24 dnq. So what we will do, we will multiply 1 mole contain 0.5 moles. Therefore, 24 dm3. Therefore, 0.5 mole contain x dm3. So you will multiply 24 by 0.5. So answer will be 12 dm3. So this should be the correct answer. Number 16. Carbon electrodes are used to electrolyze aqueous copper to sulfate. Which observations are made? We know that at anode, sulfate ion will move towards the anode and the gases will, oxygen and water will be produced. We don't have copper electrodes here. So choice C and D are automatically omitted. Now we are left with A and B. Either A is correct or B is correct. Because in both the choices at anodes written colorless gas forms. Now we'll check the electrolyte. Now they are saying blue color fades. Now again, both the choices are correct in this one also. Because copper 2 sulfate is blue in color and it fades away when copper gets deposited at one of the electrodes. The color of the copper depositing will be pink. So choice A will be the correct answer for this one. Number 17. Electrolysis is used to plate a metal coin with silver. The coin is used as an electrode in a suitable electrolyte. So if I make a electrolytic cell here, so at cathode, we have a coin and at anode should be silver. This will be the beaker. Which row is correct? Coin. Coin should be cathode. This is cathode. This is coin. Should be cathode. So you can have one of these choices correct, either C or D. Electrolyte. Now you can have either AgCl or AgNO3. AgCl is incorrect. The reason is that AgCl, in AgCl, Cl will get deposited at anode to form chlorine gas, and chlorine gas will react with silver. So we need silver ions to be compensated in the solution, and it should be coming from one of the electrode, and which is anode here. This is anode. This is silver. So AgNO3 will be the electrolyte used. This is the right choice. So the correct answer will be D. 18. An endothermic reaction has an activation energy of X. Which reaction pathway diagram is correct for this reaction? For endothermic reaction, remember the energy hump moves up, which means that when the product absorbs some energy, it should be at the higher energy state than the reactant. So you must have hump in this way. This will be the hump for endothermic process. So either A is correct or D is correct. So now we will look at the activation energy. In A, activation energy is correctly labeled, but in D, activation energy is incorrectly labeled. So the answer will be A. Number 19. The formation of liquid water from hydrogen and oxygen may occur in 3 stages. Number 1, 2H2 gas plus O2 gas gives 4H gas plus 2O gas. 2, 4H gas plus 2O gas gives 2H2O gas. 3, 2H2O gas gives 2H2O liquid. Which stages are endothermic? In the first one, H2 and O2 are broken down to produce 4H and 2O, and this is an endothermic process, so this is correct. Number 2, 4H plus 2O gives 2H2. This is combination reaction, so this can't be endothermic. Let's check the last one. 2H2O gas gives 2H2O liquid. State changes from gas to liquid, which means energy is released. Energy is released to the surrounding, or exothermic. So this is also incorrect. We are left with only one. So B is the right answer. Question number 20. In 4 separate experiments, 1, 2, 3, and 4, nitric acid is added to an excess of marble pieces and the volume of carbon dioxide gas formed is measured. In all 4 experiments, the same volume of nitric acid is used. The concentration or temperature or both concentration and temperature of the nitric acid are changed. The results of the experiments are shown on the graph. On x-axis, you have time in minutes, and on y-axis, you have volume of CO2 produced. Which statement is correct? I'm reading the statements. A lower concentration of acid is used in experiment 3 than in experiment 1. Let's compare 1 with 3. They are saying lower concentration of acid is used in 3 than in 1. This looks correct. Because if you look at the position of 1 and 3, there's a difference in the concentration of acid. So this looks correct. Now let's check the other statements. B, experiment 4 is faster than experiment 3. Let's compare 4 and 3. 4 and 3. Experiment 3 should be faster as compared to 4. So this is wrong. Statement C, choice C. The acid used in experiment 2 is of lower concentration than in experiment 1. Let's compare experiment 2 and experiment 1. 2 and 1. Which is of lower concentration? Is 2 is of all lower concentration or 1 is of lower concentration? They are saying the acid used in 2 is of lower concentration than in experiment 1. So this one is also wrong because they are saying concentration or temperature both can be changed. This looks like the change in size of the particles or change in temperature because both the experiment 1 and 2 are ending with same uniform line. You see the same uniform line. So this statement is also incorrect. Last choice, D. The temperature of the acid is the same in experiment 1 and 2. Experiment 1 and 2, if you look at this, the temperature, again, it can't be same because the line is starting and the slopes, both the slopes are different. One slope is steeper than for experiment 2. So this is again incorrect. We are left with A. This will be the right answer. 21. The equation shows the reaction for the manufacture of ammonia. N2 gas plus 3H2 gas gives 2NH3 gas. Which change will decrease the activation energy of the reaction? A. Adding a catalyst. We know that adding a catalyst will decrease the activation energy of the reaction mixture. So this looks correct. Now let's see the other statements. B. Decreasing the temperature. If you decrease the temperature, the activation energy can't be decrease for the reaction. Instead, it will disturb the equilibrium of this reaction mixture. So this is wrong. C, increasing the concentration. The concentration has no effect on the activation energy. So this is also wrong. D, increasing the pressure. Again, pressure also doesn't have any effect on the activation energy. So we are left with A. A is the right answer here. Number 22. A reversible reaction is shown. BiCl3 aqueous plus H2O liquid gives BiOCl plus 2HCl. Which changes increase the mass of the precipitate forms? This is a precipitate we are getting. BiOCl. Precipitate of BiOCl is formed. Number one, adding more water. If you'll add more water, what will happen? It will move the equilibrium to the right hand side. So this statement is correct. Number two, adding aqueous sodium hydroxide. What will happen if you add aqueous sodium hydroxide? Sodium hydroxide will react with HCl, and both of these will produce more water. More water produced means the equilibrium will shift to the right hand side. It means you will have more precipitate. So this statement is also correct. Number three, adding dilute hydrochloric acid. Definitely it will shift the equilibrium to the left hand side, which means you will have more BiCl3 and H2O. So both statement 1 and 2 are correct. So the correct answer will be choice A. 23, sulfur trioxide is produced by the reversible reaction shown. 2SO2 plus O2 gives 2SO3G. Delta H is negative in the forward direction, which indicates that the forward direction is exothermic. Which change in conditions will produce a greater amount of SO3 at equilibrium? A, adding a catalyst. You know that catalyst has no effect on the equilibrium. It simply increases the rate of reaction in both the direction. Increases the rate in both directions. So this is wrong. B, increasing the pressure. What will happen if you increase the pressure? Let's look at the number of moles of gases on both sides. I'm writing the equation here. 2SO2 gas plus O2 gas, 2SO3 gas. So count the number of gas. We have 3 moles here. If you increase the pressure, equilibrium will shift to the side which has less number of moles. So this is the right statement. So answer should be B, but we will check the other choices also. C, increasing the temperature. The increasing the temperature will shift the equilibrium to the side with endothermic side. So we have endothermic side is the reactant one. So equilibrium will shift to the reactant side. So this is the wrong choice. D, removing some SO2 and O2. If you remove from SO2 and O2, what will happen? The more SO3 will be broken down to produce more SO2 and O2. So again, this is wrong. So the correct answer will be B. For 23, the correct answer will be B. 24, iron 2 ions react with chlorine, 2Fe2 plus Cl2 gas, 2Fe3 plus aqueous plus 2Cl minus aqueous. Which statement about this reaction is correct? A, chlorine is reduced by iron 2 ions. So we will check by looking at this equation, which one is reduced and oxidized. If you look at the oxidation number of Fe2 plus to Fe3 plus, this is oxidation because the oxidation number increases. Increase in oxidation number. Oxidation number. For Cl2, the oxidation state of Cl2 is 0. So it's changing to -1, which means reduction because the oxidation number is decreased here. Oxidation number is decreased. You can even say it has lost, it has gained 1 electron. It has gained 1 electron. So choice A is chlorine is reduced. Is chlorine is reduced by iron 2 ions? This looks correct to me. Let's see the other choices. B, chlorine is a reducing agent. No, which is reduced? Chlorine is reduced. So it means it must be the oxidizing agent because Fe2 plus is oxidized to Fe3 plus. Number C, iron 2 ions are reduced by chlorine. No. Again, both of these are wrong. D, iron 2 ions are the oxidizing agent. They are the reducing agent because they reduce chlorine into chloride ion. Reducing agent because they reduced Cl2 to Cl negative ions. So the answer A is correct. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icons. In the next video, I'm going to continue CIE 5070 past paper 1.